All right, good afternoon. It is 1 o'clock, so we'll go ahead and get started. Uh, just a couple of notes, I guess, before we get started. So these sessions are recorded. They are non-mandatory and they are recorded, but this is really the best opportunity you have to be able to ask me questions directly and have me answer them live. Plus, you hear me directly talk about the material for this week's course, along with possibly giving hints or assistance with your upcoming assignment. We will hold these weekly at 1 o'clock Eastern Standard Time on Sundays. That was the time slot that got the most votes on the form I sent out. Maybe in a couple of weeks I'll send out another form just to see if it still is the best time slot for everyone. But at least for this week and maybe the next 1 or 2 weeks, this is the time slot we'll have it at. Now, excuse me, I am going to start getting into this week's material. If at any point there is something you don't understand, feel free to speak up. If you don't want to talk on the microphone or you don't have a microphone, you can put it in the chat box. I may not immediately see it, but as soon as I do see it in the chat box, I will address your concern. All right, so let's go and get started. So this is a beginner Java class. So Java is one of the computer languages, and there are many, many, many computer languages. But it's a way for a human being to tell the computer what we want it to do. And so let's start out with the very basic Java program, which I have shown here. This program will just print out hello world. There's a few key parts to this. We start off with what we have, this public class main. Now, main, it can be any name that you want it to be. It doesn't have to be called main, but main is probably the standard way that we kind of identify this is where the program starts. And as you get further along in the class, we'll see other classes besides main. We'll actually make our own classes. But for, at least the first and second week, all you need to know is this is the standard layout of what the most basic Java program is. So we have this public class main. We'll have this public static void lowercase main, and then, all this other stuff you see here. And then inside of these braces is the code that's actually going to get executed. A lot of this stuff is just kind of set up. It's our way of telling Java where our program is starting at. That's a good enough explanation for the first couple weeks. We'll get more complicated as we go along. But really, inside of these brackets right here, you can see the start curly brace and the end curly brace. Inside of here, all of this space in here is what actually gets executed by the computer. And here we have the most basic thing we want the computer to do. This is how we tell the computer to print something out. We'll say system, which you can just think of it as the computer system. We want out, which means the output. And print ln just means we want you to print this out to the console. The ln actually means at the end of it, I want you to return to a new line. So you can think about, if you have a printed line of text, and then at the end of it, you return and go down to the next line. That's what the print ln does. We could leave the print ln off, and it would still print this out, but it wouldn't put the return or the new line at the end of it. Actually, let's see both of those things. So we're going to print hello world 3 times. That's what we've done here. We're saying print hello world, and print hello world. And let's run it and see what happens. Oh, now one other note, I guess. You can see my IDE here. It's not Eclipse. My personal preference is I'm not a big fan of Eclipse. That is what the course documentation covers and explains how you get everything set up. And so you are free to use Eclipse. You're free to use any IDE. IDE stands for Integrated Development Environment. But you're free to use any program that you want when you're doing your Java code. You can use just plain Notepad if you want. As long as your program works and functions correctly, you'll get credit. I'm a fan of this IntelliJ IDEA, IntelliJ IDEA. That's my personal favorite, but you can use whatever you want to use. You're not tied solely to Eclipse. All right, but this is the one that I like to use. All right, so here we have our main function, and inside these curly braces is what's going to happen. And here we're just printing hello world 3 times. Notice I don't have the ln here. So what will happen is it'll print hello world, then it'll print it 2 more times, but it's all going to be on the same line. And the reason is I'm just saying print. If I say print ln, it'll make different lines. But let's just see it both ways. So let's do print, and I'm going to run it, and we'll see the result pop up down here. There you go. There's hello world, hello world, hello world, all on the same line. And that makes sense because I didn't tell it to make a new line. However, if we put the ln in here, that means print, but add a new line to the end. Return down to the next line. Now let's run it. And now we get the hello world on 3 separate lines, just like we would have expected. Okay? So that is your most basic Java program. Pretty much all of your programs should start off looking like this. You know, maybe not the print hello world, because all of your assignments aren't going to tell you to just print something. You're going to have to get more complicated as we go along. But at least this part right here should probably be the exact same, at least the starting framework for every assignment that you do. Now, you can see right here that the name of my file is main.java. There is something that Java is very picky about, in that the name of the file must match whatever you put right here for this public class main. They have to match. It's just the way Java operates. So for example, if I would put Bob here, for one, my IDE is smart enough to tell me, you know, something's wrong here. You know, it gives me a red squiggly line. Something's wrong here. Eclipse will do the same thing. Eclipse will give you little indications that something's not right. So the name of my file is main.java, but I made this public class and I called it Bob. Those don't match. So actually, when I try to run it, it gives me an error here. Class Bob is public and should be declared in a file named bob.java. So I can fix this one of 2 ways. I can either change this to main so that it matches the file name. That works. But if I really wanted to call it Bob, I can. I just have to also change the name of the file. If I change the name of the file to bob.java, so the name of the file is bob.java, this class is called Bob. The red squiggly line is gone. I fixed my problem. And now if I run it, oh, well, I took out my print statements. Let's do a print statement just so it prints out something. Here we go. Now I can run it just fine. There we go. It printed out. Here we go. And that's because the name of this class matches the file name now. And that's very important. But it's kind of standard convention that the entry point, and what I mean by entry point is where does your program start? It's kind of convention that you use main for it, or something like main. Like I said, it's not set in stone, but it's just kind of a convention thing. All right, so there's your basic, the most basic Java program that you can have. Okay, so let's do some things that are more interesting than just printing out. Here we go. One thing computers are really good at is doing math, is computing things, right? Well, let's have our computer do some computations for us. But first, we need to discuss something called a variable. So you can think of a variable as a placeholder or a representation for an actual value. And let me put a couple on here, and then we'll discuss the different parts of them. So say int A equals 1, int B equals 2, int C equals A plus B. Let's just discuss this for a second. So there's several different parts to these things. The first part, you see here, I have an int. That is saying, what is the type of the variable? What is the type of the value I'm going to represent? And there are many different types. We can have an int, which is an integer. We can have a float, which is a floating point number. This is 32-bit. If I can remember them all. A short is an integer that is 16 bits. And we'll discuss what the difference is between the 16, the 32, so on. The long is an integer that is 64 bits. If I can get all these right. A float is a 32-bit floating point number. We have a double. That is a floating point that's 64 bits. Not dually, it's double. And then we have three more really any consequence. We have Boolean, which stands, something that's either true or false. We have a char, which is a single character. And then we have a string, which is a sequence of characters, I guess is the best way to say what that is. So those are the different types. So you can think, if I want to store a value, or if I want to work with some kind of value, I need to know what kind of value it is. Do I want to do something with somebody's name, for example? If we wanted to do something with a name is a bunch of characters, right? So if I wanted to do some computation with a name, the variable would probably need to be a string. If I wanted to do just whole numbers, which that's what an integer is a whole number, I would use either a short, int, or long, depending on how big I want that number to be. And we'll talk about how big or how small these numbers can be. Then we have a float and a double. Those are like your decimal numbers, like 3.14, right? That's a float. But it can also be a double. It just depends on how big or how small you want the number to be. And then you have a Boolean. It's just the way that you can store either a true or false value. And then a char is just a single character. And then again, a string is a sequence of characters. Now, whenever I say, these different bits, how big or how small do you want the number to be? You have to think about that a computer, it does not have an infinite amount of memory, right? We can store stuff on our hard drive. We can store stuff in the memory of our computer, but it's not infinite, right? So we have to put, limits on how big or how small something can be. And so we can decide here that if we're using really small numbers, maybe we just want it to be a short so that we use a smaller amount of memory. Or, if it's within the range of an integer, or if it's in the range of a long. So we just have to kind of decide which one to use depending on how big or how small those numbers are going to be. So we'll talk about how big or how small in a minute. I want to get back to actually making these variables with these types. So here I have made these three variables, and the type of each one is an int. So that means it is a 32-bit whole number, right? I could have made it float, and they could have been decimal numbers. But for my example, I know I want them to be integers. So I'm going to say the type of the value is an integer. And the next thing here, we have this A, we have this B, we have the C. That is going to be the name of the variable. That means if we want to use that value at some later point in the program, this is what I'm going to call it. I'm going to say I have an integer. The name of that integer is A, and it is equal to the value 1. So anywhere else in my program, whenever I see that A, you can kind of substitute it as being the value 1. And we've done the same thing here with b. We're saying I have an integer. The name of the integer is b, and it has the value 2. So anywhere else I see the b, you can kind of mentally substitute that it is actually the value b. And then finally, we have another integer. I'm calling it c, and I'm going to say it's equal to a plus b. Does that mean that c is going to be ab, like a string ab? No. Remember, I said a, it is the value 1. B, it is the value 2. Right there, I said b is equal to 2. So the computer is going to add a plus b. So it's going to add 1 plus 2. That'll give us 3. So c is equal to 1 plus 2, which is the 3. Let's print all of those out. Print ln. Oops. We're going to print the a. We're going to print b. And we're going to print c. Let's get rid of the hello. Here we are, the hello world. We don't need that. So here I've made 3 variables. They're all integers. I've set their value, and now we're just going to print them out. So let's run that. There we go. It's 1, 2, 3. And is that right? So we're saying print out a. Well, a is 1, and we printed 1. That works. We're saying print b. B is equal to 2. We printed 2, so that works. C is equal to a plus b, which is 1 plus 2. So C is 3. We print C, and 3 is what we printed out, so that works. So that's how we can use variables to do some kind of mathematical operation later. You can think of it as a representation or a placeholder for the actual value. Okay? And we can do lots of different math. This actually is getting into the next thing, is we don't just have addition. We have subtraction. We have multiplication. We have division. You have to be careful with the division, though, and we'll see why here in a minute. So actually, let's do each of those. Let's change this to be 3 and 4. Okay, actually, let's do 5 and 4. And let's do each of the math operations that we know of, right? So we have C, D, E, F. So we'll have A plus B, we'll do A minus B, we'll do A times B, we'll do A divided by B. So let's print out all of those things. We'll just do the math ones. So C, D, E, and F. Okay. So we're going to say A is the number 5. It is the value 5. B is the value 4. So then we're going to do A plus B, A minus B, A times B, and A divided by B. So what should these be? Let's think in our head what these should be. So A plus B, that should be 9, right? A minus B is 5 minus 4. That should be 1. So let's put what we expect. We expect that to be 9. We expect that to be 1. What is A times B? 5 times 4. We expect that to be 20. What is 5 divided by 4? 5 divided by 4 is 1.25, right? Well, let's print out each of these and see if it matches. Let's run it. See, we get 9, so it added correctly. We get 1. We expected 1, it added correctly. We get 20. We expected 20. But we only got 1 when we expected it to be 1.25. Why is that? What went wrong in our program? Actually, nothing went wrong. And this is a consequence of the type of variable that we chose. So the problem is here in the F, right? The A divided by B. But we said it's an integer, and integers are only whole numbers. An integer is only a whole number. So, and the A is a whole number, right? The A is an integer. The B is an integer. So when you do division with just integers, you get an integer answer back. Does that make sense? So in reality, if you were doing this on a calculator or on a piece of paper, this is what you would have calculated the answer to be. But since we're only doing whole numbers here, which is what the integer means, we only get a whole number result, which is what the 1 is. Now, however, if we would have went through and we would have said, okay, instead of working with integers, I want these to be floats. I want these to be decimal numbers. Now let's run it. We see we get 9.0, that's right. We get 1.0, that's right. Get 20.0, that's right. And we get 1.25, so that matches. So now it gets a little more precise. So the type of, I guess the point I'm trying to make is the type of variable you choose, you want it to be, it needs to reflect what you want to do with it. If you want to do some math computations that involve decimals, you have to choose a float or a double. A double also does floats. It just has a bigger range. It uses more memory, but it'll give you a lot more bigger numbers. So that's kind of the integer family, which is there. That's kind of the float family, which is there. Let's look at the Boolean. We can have a Boolean. We'll just say the value is equal to true. Let's print this out. And this should print out with no surprise. True. The Booleans are really used for what we call flow control, and we'll get to those in probably about 2 weeks from now or so. You don't need to worry about too much right now, but it's just a way that you can represent a value that is either true or a value that is false. So we change it to false and run it, and we print it out, and of course we get false. It may not look important now. It is very important once you get to flow control, which I think is in 2 or 3 weeks. Okay, and then kind of the last two we have are a char, say it is equal to an S, and we'll have a string. Oops. That's how we kind of make those. This char is the type, so it means it's a single character. The C is the name of the variable. We're saying it's equal to this single character S. Notice here the difference between a single quote and a double quote. The single quote means this is one single individual character. The double quote means it is a sequence of characters. It is a whole string of characters. Let's print each of these out. And one thing I want to note is, say if we put this in here, is this a character or is it a number? Is this a string or is it a number? This is a character. This is a number. Excuse me. Sorry. This is a string. It is not the number 1, 2, 3, 4. You can't do like the addition and subtraction and multiplication and division. You can't do that with these because these are just the character 1. It's not the actual value 1, but it is the character 1. Just like this is the characters 1, 2, 3, 4. It is not the value 1, 2, 3, 4. There are ways you can convert between them, and we can get to that in the future. But for starting off actually this is the second week. For the second week, you just need to understand that this is not the actual numerical value of 1. It is just one single character that looks like a 1. And the same thing with the string. So now if we run this, of course, we're just going to print out the 1 and print out the 1, 2, 3, 4. So I'll touch briefly on, we'll do this for the integer family and the float family. I told you that, you need to choose these based on how big or small of a value you want. Well, let's see what the range is. We're going to use some Java here to print out the biggest and the smallest. Think short dots, min. Yep. What this is going to do, it's just going to show us what the biggest and smallest values are. Let me do this for each of the integers. Just so you can see what the biggest and smallest values are, so that it helps you decide which ones that you want to use. So that's the integer family. Let's do the float and the double real fast, and then we'll move on. So what I'm doing here, I'm just telling it to print out the minimum value, print out a space, and then print out the maximum value. And I'm doing that for the shorts, the integers, the longs, the floats, and the doubles. Let's run that. So you see here, so that is the smallest and biggest value that you can have if you use a short. So it's, just a little over 30, minus 32,000 and change to positive 32,000 and change, right? So if you are using numbers that are only within that range, then you could use a short as the type. If you wanted bigger numbers, then you can't use a short. You might use an integer. This is the integer. You can go from, I think that's like 2 billion. So it's like minus 2 billion to plus 2 billion, give or take a little bit in there. That's kind of the range of numbers you can have for an integer. And for a long, that's 1, 2, 3, 1, 2, 3. I don't even know what number to say for that. That's thousands of trillions or something like that. So it's a really big number, a really, really small number, actually, because it's negative, up to a really big positive number. So if you were using some really big numbers, you would want to use the type of long. Now, you can have numbers bigger than this, but it's kind of beyond the scope for this class. But for this class, those are really the three you need to be thinking about. And then here we are with the float. So, this uses scientific notation, but just think of it as, this number, but with 45 zeros in front of it. All right. And the double, 300, and this is like 4.9 times 10 to the negative 324th power. Actually, I'm sorry. Yeah, that's the smallest. 4.9 times 10 to the negative 324, exponentially small, up to 1.79 and change times 10 to the 308th power. Really ginormous numbers. So you just need to, even the float by itself is really a big number. So when you're doing your programs, you just have to decide kind of, what range are my numbers in, so you can decide what type of variable you want to have. One more time, simple example with variables. Let's say I have actually this is variables and operations. Operations being, plus, minus, divide, subtract, so on. So let's make a little program here that uses variables, and let's say it computes the area of a circle, right? What's the area of a circle? The area is equal to 2 times pi, it's pi r squared, right? Yeah. Pi times r, right? That's the area of a circle, right? That's pi r squared. That's just basic algebra stuff. So let's make a program here that computes the area of a circle for us. So first we need to have a variable for pi. So let's say a float pi is equal to 3.1415927 and some other stuff, right? All right. Let's make an r. We'll say the radius is 5, right? So now to compute the area, so we have a variable of type float. The name of it is pi. It's going to be equal to the pi value that we know. Now we're going to have another variable. The type is float. The name of it is r. It is equal to 5. That's the radius of the circle that I want to compute. Instead of just r, let's actually make it radius. It's more descriptive. That's a very important thing about variables is that you name them something that kind of represents what it is they do or what they represent. So since this variable is going to be our radius, let's just name it radius. So now let's compute the area. So the type is float. The name of the variable is area. And we're going to say it is equal to pi times the radius times the radius. And now let's print out what the answer is. So now we will print it out. Let's run it. See down here, it prints out 78.53982. And you can break out a calculator to see if that's correct. It's correct. So variable type, variable name, the value of it, the same thing for the radius, the same thing for the area. And then here, I'm just printing it out so that we can see what the computer figured out for us. All right. Only really one more thing to discuss for the material so far for the class. And that is of getting input from the user. All right, before I go on, I have a hand raised. Go ahead and ask your question.
Hi, Professor. I was curious why is it necessary to put the F at the end of those float variables? Whereas with with a double, you can just put a 0.0 or.
Yep. So the reason why I put an F here is I'm telling it that this number is a floating point number. If I leave off the F, then Java thinks this is a double. It's just a way for you to specify what the type of the number is. So yeah, we put the float here, and the float says what the type of variable is. But on the right-hand side of the equal mark, this value needs to be the same type as what you said the variable was. So if the variable is a float, the number needs to be a float. And the way Java works, not all programming languages are like this. Java is like this, is that if you just have a number with a decimal in it, then Java assumes that is a double. But if we put an F there at the end of it, I'm specifically telling Java that this is a floating point number. So if I would leave the F off here, that would, if I put a double here and I say, okay, the type is a double, then I can leave the F off there. And that works fine. It's complaining about some other stuff, and I'll explain that in a second. But without the F, Java assumes this is a double. And so the name of the type of the variable has to be a double as well. It's kind of the same thing. If I would put, string S, I can't put 1, 2, 3, 4 there. It's going to complain about that because this is a number 1, 2, 3, 4, but I said the variable is a string. So those two things don't match up. And so Java doesn't work like that. So that's the same thing with why I'm putting like the F here, because I said the type was a float. Now, the reason why, after I changed this to double, the reason why, okay, this is complaining now is because I'm taking a double times a float times a float. Now, whenever you're doing math, the answer, the result for this is kind of like the type of the biggest number that you're using, if that explanation kind of makes sense. So this is a double, this is a float, this is a float. Out of all three of those, double is the biggest one. And so the result of this math is a double. And then it runs into the same problem. Well, okay, I said it's a float, but the result of this is a double. Since those two things don't match up, Java is complaining to me. So I can fix that one of two ways. I can turn this back to a float so that all three of the numbers are a float. And then, those match up and that matches up. If I wanted to keep this as a double, then my answer has to be a double as well, because pi is double, radius is float, radius is float. So out of all of those, double is the biggest one. So my variable needs to be a double as well. If we run that, we see we actually get the same thing. Well, we get the same thing, but you can see it's actually a little more precise, right? I think the first time was just like 5398 when we use just floats. But when we're also specifying a double, we get 5398175. It's just a little more precise. And that's because the double, it can be bigger and smaller numbers because it has more memory associated with it. But to answer your original question, the F is there to explicitly specify this number is a floating point number.
Thank you.
Okay. All right. So, like I said, going into the next thing, and it's really the last of the new material that we have for these first couple of weeks, is getting input from the user. I just want to change this back to float for right now. Okay, so this program works perfectly fine for computing the area of the circle, right? So if I want the area of the circle, I have to compile the program and run it, right? If I want to know the radius of a different circle, I have to come in here, I have to change my code, I have to compile it again and run it again, right? That's the area for radius of 2. If I want another radius, I have to come in here, I have to change my code, I have to compile it and run it again, and it gives excuse me, and it gives me the answer, right? Well, what if we want to be able to do this computation without having to go and continually change my code, without continually having to recompile it and start it running all over again? Think about like the calculator app that's included with Windows, or even the calculator app that's on your phone. At the core, they work the exact same way. You do not have access to the source code of those programs. You can't go in and modify the source code of those programs. If you make a program and you sell it to somebody, it's very unlikely you're going to give them the source code, so they can't go in and modify it. So you need to provide to the user a way for them to put input into your program, have it do whatever computation or whatever work you want it to do, and then give them back an answer. If you think about the calculator, that's exactly what it does. It lets you put input into it. Behind the scenes, it does some kind of computation, and then it gives back to you some output when it shows it on the display screen, right? So let's modify our program so that we let the user give us the input. We'll let the user tell us what is the radius of the circle you want to compute. Then we're going to do the math for them, and then we're going to give them the answer. So here's how you get input from the user. We use a thing called scanner. Usually just like this, it's called scanner. That is the type. Remember we said there were these different types here, this short, this int, this long, this float, double. These are what we call the basic types. These are kind of the most, I don't like using the word in the definition of the word, but these are the most basic types of information, of variables that you can have on the computer. And everything is really built on top of these types here. These are at the very bottom, if you can think of like a pyramid. Okay. One of the things built on top of it is this thing called a scanner. It is a type of its own, a lot more complicated than these, but Java does this for us. It's called scanner. What it does is it allows us to get input from the user. We can actually use it to get inputs from files and from the network as well. But we'll start the basic steps here, and we're going to use it to read input from the user, specifically from the keyboard. All right. So this is the type. We have to give it a name. We'll just call it scanner. Notice that I can do this because uppercase is different than lowercase, meaning this scanner with a capital S is different from scanner with a lowercase s. These are two different things. So this is the type of the variable, and this is the name of the variable. I can't use a capital S there because then they're the same thing and you can't use the same thing. So we'll make it a lowercase s. So we're going to make a scanner which allows us to read input. And the way you make it is like this. This whole thing with new and everything like that, we'll actually get into what those things actually do behind the scenes here in a couple of weeks. Actually, I think about 3 weeks. But at least for the first week, all you need to know is that this is making a scanner. The type is scanner. The name of it is scanner with a lowercase. And it's going to be equal to this new scanner with this system.in. The system.in just means it's input from the keyboard. The new scanner is saying we're making a new variable of type scanner. And for this scanner, like I said, what it does is it reads input. And we're going to say the input we want it to read is from the keyboard. And that's what the system.in means, is it's from the keyboard. So how do we get the input? We can get it something like this. Just say string s is scanner dot, you just say like next line. What is this doing? This is taking our scanner variable, our scanner, which is reading input from the keyboard, and I'm saying, give me the next line that the user types in. If we hover over this, Eclipse should let you do this as well. But when we hover over it, it'll actually tell us all kinds of things about this function we're using called next line. It tells us, advances the scanner past the current line and returns the input that was skipped. You can read all the information there. But what this essentially does is whatever the next entire line that the user types in at the keyboard, we want you to give that to us. What I'm going to do real fast, I'm going to comment this code out. You should have already seen this before. Is when we comment the code out, it just means this doesn't actually get executed. I don't want to delete it because I want to use it later. But when it's commented, meaning we can comment a single line with the 2 slashes, or we can comment multiple lines by a /* and then the other /* to end it. So that really the only thing that's going to run now is this stuff right here. So let's run this, and then we'll print out what the S is. All right. So we're going to make a new scanner to read from the keyboard. We're going to tell the scanner to give me the next line that's typed in, meaning the entire line. So if I type a whole bunch of text, it's going to keep going until I hit the enter key. Once I hit the enter key, that is the next line. So this keeps going until I hit the enter key. And so whatever I typed in is now saved in that S variable. And then I'm going to print out the S. So let's run this. And so it doesn't look like it's doing anything, but it's actually waiting for me to type something in. So let's cancel this. Let's do something so we know what we want to do. Let's tell the user that we want you to do something. Enter some text, and not test. text and press enter. So that instead of looking like it's not doing anything, we know what's going on. So when we run it, there we go. Here it says enter some text and press enter. And that's right, because the first line of our program is to print that out. The next line in our program created that scanner, which is going to read from the keyboard. The next line is it's going to read from the keyboard the next line. So it's actually waiting for me to do this. It's waiting for the user to type something in. So let me just put in my name. But it's still waiting for me to press enter. So if I press enter, then it prints Dan. Why does it do that? Because scanner, it gave me back whatever I typed in until I pressed enter. And so I said my variable S is equal to whatever was typed in. And so now I'm just going to print it out. Let me run it again. Let's type in a lot more stuff. A lot more stuff than just one word. And then this, and then this, whatever. Right? So now when I press enter, that was everything that I typed in. And so that's what I get printed out. So this next line lets me get a string. Let's run this again. Let's put in 1, 2, 3, 4, 5. And it gives me back 1, 2, 3, 4, 5. So can I do the math with that? Imagine I want to run my program and I want to know the area of a circle with radius 10. If I put in 10, there's my 10. So that's what it printed out. So the S is the 10 I typed in. Can I do the math with that value? And I can't. And it goes back to what I said, is that a string, it may look like a number, but it is not actually that value. It is the string. It is just some characters that look like a number. It is not that actual number. But let's get the actual number. So the scanner dot next line gets a line of text. There's another one called next int. That will get me an integer. And of course, the squiggly line is complaining that, hey, this is an integer, but this is a string. So it goes back to what I was talking about earlier, that both sides have to match up. So if I change this to an int, it stops complaining to me. So now this will give me whatever integer I type in. So if I run this, now if I type in 55, it looks like it's doing the same exact thing, right? However, this time it actually is that actual value. I can do the math with it. And I'm not limited to integers. I can do a float, but that means over here, I need to do next float. That works. So if I run this, now I can type in 10.5, and there we go. I have the value 10.5. This is no longer the string. It is that actual value. And it's the actual value because I told it, give me a float. Not the next line. If I did next line, it's just text. It's just characters. But this gives it to me as a float. Same thing, we can do a double. Of course, we have to change this to double and run it. Now, if we type in some numbers, not letters. There we go. So it is this actual value. So when I typed in those letters, you might have wondered, okay, what happens if I type in letters? Is this going to work? So I'm telling the scanner to give me the double, and I'm saying that it is a double. What's going to happen if I try to run this program, but I don't give it what it's expecting? It's actually going to crash. This is what a kind of a crash looks like. It tells you there's an exception. It tells you it's in main, which this is our main. And it tells you a bunch of stuff. Fortunately here, the very bottom line tells you exactly where your program went wrong. Main.java, line 16. So the crash happened right there. And it's because I told the scanner, give me a double. The variable is double, but what I typed in is not a double, right? It's, you don't have letters inside of a number. So it kind of crashed. For your assignments, I don't need you to worry about this too much. You can assume that I will give your program the type of input that it expects. But just whenever you're making your programs, and you see these crashes and stuff like this kind of gives you a hint at what might be going wrong. Okay, so now that we've done this input from the keyboard and we're able to get these values, let's do our math with it. So I'm going to make it a float. I'm going to call it the radius. I want to be the next float. So instead of saying enter some text, let's just print out enter the radius of the circle, right? This is just an indication so that the user knows what we're waiting for them to do. This is usually what we call a prompt. It's just some text to the user that prints out to the user so the user knows what it is they're supposed to be doing. So we're going to tell the user, hey, enter the radius of the circle. We're going to make a scanner so that we can read from the keyboard. I'm going to read that radius as a next float. So now let's compute our area with this radius. Let's make all this stuff uncommented. We don't need this radius anymore because we're having the user type it in. Let's get rid of that one. So is that everything we need? Let's look at it line for line. So print out to the user, hey, enter the radius of the circle. We're going to make a new scanner that uses the keyboard input. We're going to read the next float from that keyboard input. And pi is still pi. The area is still computed in the same way. So we're going to use our pi, but we're also going to use the radius that the user typed in. And then we're going to print out the area. So let's run it. Now we can see enter the radius of the circle. Okay, what's the area when the circle has a radius of 1? Yep, that's the area. Well, what if the radius is 2? We don't have to go change the code for our program. We just have to run our program again. So let's say radius of 12. There we go. That's the radius circle with the area of a circle with radius 12. Let's run it again. We can use about any radius that we want. There you go. That's the radius. Excuse me, I'm sorry. That's the area when that's the radius. And notice we don't have to change anything in our program because this lets us get from the user what it is they want to compute. The only thing you have to be careful of is, like I said earlier, is there are some minimum and maximum values for floats. So if we use a really big floating point number, I don't know, maybe this is too big, maybe it's not. Yep. It tells me it's infinity, and that's just Java's way of telling you, yeah, hey, this number is too big for floats. Actually, that number is probably too big for a double. Let's change it to a double and just see what happens. It's probably too big for a double. I don't know how many numbers I typed in. Well, it wasn't too big for a double, right? A double was big enough to handle, that computation. Okay. Oh, no, there is one that's all of the Java specific coding things that you've had to know so far for week 1 and 2. The next really important thing I do want to talk about is test cases. Let me share a different part of my screen, because this is very important. Fortunately, I have too many students have problems with this every semester. Okay, so you should be able to see my web browser up here now, I believe. Okay, so test cases. This is actually in your learning material. In week 2 under software testing, you really need to pay attention to this section, right? This section talks about, not that one, this one. This section talks about, how do I know if my program is operating correctly? Okay, this is what you need to include every time you do an assignment. For every assignment submitted, the assignment will tell you you need to do a test report, and this is the format of the test report. Notice it's a table, all right? The first column is test case. Those are just sequentially numbered. How many ever you do. You usually need to have a minimum of 3. The input is, what is the input that I supply to my program? Here in a minute, we'll do one for the area of the circle. We'll do a test report for that. All right. The next column is the expected output. The expected output is, if I give my program this input, what should it tell me the answer is? The expected output, and I can't stress this enough, this is something that you need to manually compute yourself. This is not what your program tells you. This is what you yourself have manually computed. When I say manually, you can use a calculator. Using a calculator is fine. But do not just run your program and put that here. That's not what goes in expected output. And we'll see why here in a minute. So the expected output is, okay, if I give my program this input, what do I expect it to tell me? That's the expected output. The actual output is what your program tells you the answer is. So if I give my program this input, my program says this is the answer. So now the result is you compare these two things and they need to be the same thing, right? So what my program tells me is the answer should be the same thing as what I expected the answer to be. So that's either a pass or a fail. So let's look at why that's important. Let's go back to the other sharing. Where's it at? There we go. Workstation. Okay. So how does that work for our program? Remember, I'm going to do a kind of a crude chart here. These work really good if you put them in like a spreadsheet or something like that. You don't have to, as long as you can make this table. But for just so it's easy to display to you, I'm just going to put it here in my program as a comment. So we have a test case, we have the input, we have the expected output, we have the actual output, and we have the result, right? So this is my table. So let's make a couple test cases. So when we're testing my program, I'm going to say, okay, the input, this time it's going to be 1. What does that 1 represent? It's the input to my program, right? And so the input to my program is what? It is the radius, right? I'm trying to make these line up. So let's do a manual computation here. The calculator. So we know the formula. So if the radius is 1, what should the answer be? Should be pi times 1 times 1, right? So the answer should be 3.14. You know, I'm rounding off a little bit. We'll get what the actual output is. We'll get it in a minute. Let's make a couple more of these test cases to test it out. We'll say test case 2. The input here is going to be 3. So what do we expect the answer to be? Let's get our calculator again. So it should be pi times the radius times the radius. The answer should be 28.26. Let's do one more. And let's say we did radius of 15. You know, what do we expect the answer to be? All right, what's pi times the radius times the radius? Should be 706.5. All right, now let's go through and get the actual output. The actual output is, what does my program tell me the answer is? So let's run it. All right, so let's do our first test case. The input is 1, so let's put 1 here. And it tells us, actually, let me change this back to float. Let's change pi just down to the approximation we're using. All right, now let's run it. All right, so our first test case is with the input of 1. So with the input of 1, it tells me the answer is 3.14. Is that a pass or a fail? That's a pass. They match, right? 3.14, 3.14. So my test passes. All right, let's try with 3. Let's run it. 3. It tells me the answer is 28.26. And that also passes because they match. This is what I expected it to be, and this is what it actually computed. So it passes. And let's do the last one. Let's say this is 15. Tells me it's 706 and some 5 with some rounding stuff in there. The rounding, yeah, I'm not too worried about. 706.5. That also passes. Okay, so to me, this is a good indication that my program is operating correctly, right? So, what's the point of this? The point of this is to help you catch an error in your program. So let's imagine we do have an error in our program. We'll keep the same test cases. We'll keep the same test cases. So we still expect that output to be the same, but let's say instead of this, the pi r squared, let's say we made a mistake in our computation, right? Let's say instead of times, we accidentally put plus. Okay. So there is a bug in our program, right? And this will help us catch it. So the expected output is still the same, right? Because when you have a radius of 1, that is the answer. We manually computed it. But let's run our program. Let's test if our program is working right. So if we put in 1, we get the answer of 4.14. That fails. There's something wrong with our program. Now you can go through and do the other test cases. We do 3, go 12.42. Oops. That fails. And let's do the last one with input of 15. It's 62.1 and some rounding. That also fails. So this is telling me I have a bug in my program, right? Whenever the actual output does not match the expected output, something's wrong. So let's go through here and try to figure out what went wrong. We start reading through it. Oh, here's where I have the bug in my program. This is supposed to be a multiplication and not addition. Okay, let's fix my program. After I fix my program, I have to run my test cases again. So we fixed my program. At least I think we fixed my program. I put in 1, it gives me 3.14. I put in 3, it gives me 28.26. If I put in 15, gives me 706.5. So you can see all three of those now pass. So we can add the, the pass on here. So now my test report, which is what this is a test report, this table is complete. Everything passes. So it's a very strong indication that everything in my program is right. It's not 100% foolproof, but it's a very strong indication that I've done the program correctly. So this will be the last word to note, and then I'll take a couple questions. I do have a hard stop time of 2:15, about 10 more minutes. But let's say I did this instead. Let's say I was being lazy. And if I catch you being lazy doing this, unfortunately, at least for the test report portion, you're going to get a 0. So let's just keep that in mind when you're doing these test reports. So let's say we have this same test case and the same input, but let's say I don't feel like manually computing this, but I have a bug in my program, right? This is a bug in the program that should be multiplication, but I accidentally put addition. So there's a bug in my program, right? It's not correct. But I'm being a little bit arrogant, and I'm thinking to myself, there's nothing wrong with my program. I'm too good. I never make mistakes, etc., 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 right? And so I don't want to go through and manually compute these answers. I'm just going to run my program because I know my program's right. Being sarcastic here. I put in 1. Okay, my program says it's 4.14, so I'm just going to put that for both of these. And it passes. We'll do one more of them. I run my program again, put in my next one. It tells me it's 12.42. And since I'm so good and I know my program is always right, I'm just going to put it in for both of them because I'm arrogant and I assume I don't make mistakes. Okay. So what has went wrong here? And just assume I did the third one. Well, we'll do the third one just to get it completely filled out. And I only got a couple minutes left. 62.1. And I say it passes. So what's wrong here? So I have a test report that says everything passed, but clearly my program is wrong, right? But my test report said everything was fine. What is the mistake I made here? The mistake is that I just assumed my program was correct, and I did not manually compute the expected output. I just said, okay, my program told me it was this answer, so I just put it in both columns and say it passes. That's actually a little bit fraudulent because you're not doing the appropriate work. You're not manually computing this expected output. So make sure you're doing this the right way. Make sure you're manually computing this expected output, then comparing it to what your program actually displays and making sure that they match. Like I said, what will really bite you in the butt if you don't do this the correct way, if you just take the lazy approach here, then whenever I'm grading your assignment and I see you make this mistake, but all of this says pass, 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 then I'm going to know that you didn't do it correctly, right? And if I know this is the way that you did it, then at least for the test report portion, it'll be no points earned for the test report. Okay, so make sure you're doing this the correct way. And the point is, I hope that you've seen here is it helps you identify if your program is working correctly or not. And I'll tell you, in the real programming world, if you go on, after you get your degree and work for a company, doing testing, extensive testing, is one of the most important things you can do on your software. Okay, so I have about 6 minutes left before I have a hard stop. So I'll open it up to any questions you may have.
Hey, Professor, does the testing have to be done in Java? Or I think I saw that it was supposed to be in a Word document.
Yeah, no, that's what I was saying. As long as you have this table, you can put it in a Word document, you can put it in a spreadsheet, whatever is easiest for you to work with. I actually prefer that it is in a separate document. Uh, on this computer, I don't have Word, so I couldn't open up Word and put it into Word. But yes, any kind of document that you want to put it in is perfectly fine, and that's actually preferable. I just typed it in here because I don't have Word installed, and so that you can see, what it looks like. But yes, certainly put it in whatever document format that you want.
Okay, thank you.
I have a question about the doubles and floats again, I guess.
Okay.
I,
Okay.
I was kind of sticking to doubles for the most part because the text said it was the default. Is that going to be like downgraded because I guess maybe it's taking more memory than it needs to?
No, you can use double or float, whichever that you want to use. Yes, double does use more memory. If we, look up here at the top, I mean, it's almost inconsequential. I mean, so this is 4 bytes. Sorry, that's an integer. Still, the float is 4 bytes. The double is 8 bytes. So, if you're only using a couple of them, the amount of memory is inconsequential. Now, if you had like a database and you had hundreds of billions of these numbers, it starts to add up at that point. But for your assignments, if you use a float or if you use a double, you can absolutely use either one of those that you prefer. What you do have to look out for though is if you're using numbers that are only whole numbers, then you need to use one of these. If your numbers involve decimals, you need to use one of these. So, like if you're using a double to count the number of days or to count apples, that doesn't make sense. And I would expect you to use one of these that's a whole number. If that makes sense of where you should definitely use one of these or the other. But between double and float, that's completely up to you, whichever one that you would want to use.
Thank you.
Okay. All right, I have to wrap this up. I have somewhere I have to be. Like I said, this is being recorded, and I will get it posted up on the course site here later on this evening, and I'll make sure I send out the link for it so you can all go back and review anything that we went over if you need to look at it a second time. Thank you all for being here, and have a good rest of your weekend.
Bye. Thank you.